Good day, ladies and gentlemen. This is Sarel van Grinnen, aka Mr. VG, and I am now so excited to almost be done with trigonometry in this question paper. This last question in the November 2021 Department of Basic Education Trigonometry section is all about solving triangles. So this is actually kind of the crux of the matter of why we do trigonometry. I know some of you might have completely forgotten why you actually do trigonometry. And actually you do trigonometry to solve real life problems. Problems like this. So I'm going to encourage you, take time out, hit the pause button, try it yourself, and then you watch the rest of the video. Don't just go and say, yeah, I know, and I'm just going to watch the rest of the video and I'll get it in the end. You can't do maths like that, ladies and gentlemen. You can't do maths like that. Please, please, please do not do the oh yes method where you look at my videos or the memo and go, oh yes, I know how to do it. You've got to try it yourself. Now that you've tried it, or I hope you've tried it, let's go and look at this kind of sum. Now I've got a secret to this sum. And my secret hasn't really often let me down. It's very seldom that my secret let me down. So what I love to do is, first of all, draw my triangles. Take this weird, strange question, and after filling in information, I'm actually going to blow it apart. So I'm going to draw my triangles apart. But let's look at the information first of all. It says there in the diagram below, T is a hook on the ceiling of an art gallery. Point Q, S, and R are on the same horizontal plane, and the angle of elevation from Q to T is X. So basically, there's nothing new that the sketch has not shown us. I've got that purple triangle at the bottom there. And then I have X as being my angle of elevation. There's nothing really interesting there. So what I'm going to do now is I'm going to blow my triangle apart, or that sketch apart, into different triangles. First of all, angle TQS. Secondly, angle QSR. And last, triangle TSR. There is also triangle QTR. That's kind of flat, but I'm not going to worry about that one now. But again, just be aware that that is my flat one there. Okay? Not going to spend much time on that, but let's now look at the rest of the information. First of all, it tells me those two sides are the same, QS and TS. Which means I've got an isosceles triangle. That's why I put the X already at T. Please don't forget, you also have interior angles of a triangle, which means angle S is 180 degrees minus 2x. That's all the information I have in that little triangle. Next up, in triangle SQR, what do I have? I have that angle R is X, angle S is 90 plus X, and QR is 5. What must I not forget? Interior angles of a triangle, angle Q, I can get from that. Wow, I'm a poet and I don't even know it. So I know that to get angle Q, I've got to take 180 minus the X minus the 90 minus X because of interior angles of a triangle. So 180 minus 90 gives me 90, and negative X minus another X becomes negative 2X. What else do I have? that in that top triangle, I only have that TS is the same as QS. So I'm just going to put that little line in there. And that, ladies and gents, is all I have for now. Let's look at now actually trying to get the answer of the first question. So it says there, prove that QS is equal to 5 tan x. Now, automatically I see that 5, and I'm thinking I must work in triangle SQR because there's a 5 in it and there's an x. None of the other triangles that I have actually have a 5 in it. And so I'm going to look at this and I'm going to ask myself, how can I do this? But how do I approach the sum? That is the important question. I approach the sum by first of all asking myself, is there a 90 degree or not in this triangle? There's no 90 degrees, so I know that I'm going to work with sine, area, or cosine rule. Because there's no 90, I'm asking myself one of two questions. Either I'm working with 2 angles, or I'm working with 3 sides. That's basically my 2 options. Now, I don't have enough to work with 3 sides. So I'm going to work with 2 angles because 2 angles have been given to me. So I know I'm going to use the sine rule. If it was 3 sides, I would have worked with the cosine rule. That's a very, very easy way. I've taught my students how to choose between the sine and the cosine rule. So looking at the sum, if I now just mark the little s and the little r and the little q, the lowercase letters on there, let's write out the sine rule. S over sine of angle S is equal to R over sine R. You will see I forgot that little copy there. That's fine there. Let us substitute the values we've got in. Small s is 5. Angle S is 90 plus x. And angle R is x. What am I trying to get? I'm trying to get QS. So I'm going to multiply that sine x to the top, leaving me with 5 sine x over sine 90 plus x. Constantly, ladies and gents, there's a 90 minus x. Let me just get a different color here. There's a 90 minus x, and there's an x there. So I know I've got to work with that 90 plus x. Now the 90 degrees is going to tell me that sine x is going to change into cos x. But 90 plus x is in which quadrant? Well, that's quadrant 2. And sine is positive there. So therefore, I have a positive there. Now, what is the identity for sine x over cos x? Well, that is simply tan x, which means I've proven what I wanted to prove. I've got my tan x and I've got my QS there. Sure, what a beautiful, beautiful sum. Not that difficult, but I hope that you get my way of thinking. Is there a 90 degrees, yes or no? If it's no, am I going to work with sine or cosine? Let's quickly have a look at question 8.2. Okay? Question 8.2, it says there, prove that the length of QT is equal to 10 sine x. Now QT, I'm going to work in that triangle. because it is the triangle that has the next most information in it. But remember what I calculated in the previous sum. I proved that QS is 5 tan x. And ST is also then 5 tan x. Simple and as easy as that. Remember my elimination now. Do I have a 90 degrees? Yes or no? No, I don't. But I have got two angles. So I'm again going to go towards the sine rule. So the sine rule for QT, remember, fill in your lower cases. S over sine S is T over sine T. Now, small s is QT, what I'm looking for. Sine of S, remember, S is now 180 minus 2x. Small t is 5 tan x. And capital T is just x. I've got to now say, I'm looking for QT. So I'm going to multiply that denominator to the top of the right-hand side. Simplification or reduction is going to make my angles more manageable. So the 180 minus 2x, that's in quadrant 2. So sine is positive there, leaving me with that beautiful expression. But am I getting closer to where I want to go? I'm getting closer, but I've got to look that QT, I want this sine x, not 2x. I want sine x, which means that sine 2x, I've got to go and expand now. I don't have another choice because of the angles not being the same. So sine 2x and tan x, I'm going to expand into their identities. Because again, I don't want tan x in my answer, I want sine x. So I'm going to expand both the orange, the tan x, and the sine 2x. And let's see where this goes. So the cos x and that cos x cancels out. They divide away. Sin x and sin x divides away. What am I left with? 5 times 2, which is 10, and a sin x at the top. Yes! Got it! Awesome! I feel so good when I get maths right. Man, it's the most emotive subject on this planet. There's nothing as good as getting a math sum right. That might be debatable, but we're not going to talk about that today. Let's have a look at the next sum. The next sum, it says now, calculate the area of triangle TQR. Now, we haven't actually drawn TQR. So let's quickly draw it. That is that slanted one, the one triangle we didn't draw. I've got QR as being 5. Remember, that was given originally. Next up, they tell me that angle TQR is 70 degrees, so I'm going to write that in. And don't forget what you just did in 8.2, that QT is 10 sine x, but x is 25 degrees, so I can substitute that in. Always remember what you did previously, ladies and gents. So what is the area rule? The area rule says a half of T times R times sine of Q. I like to think of 2 legs and the angle in between. Put your palms together, the base of your palms, and clap your hands. That is the way you need to think of the area rule. One side, another side, sine of the angle in between. So T is 5. R, little r, is 10 sine 25. and Q is 70 degrees. So therefore, the area is 9,92 units squared. Please don't forget about units squared, because it is a unit. Well, it sounds weird to say unit squared is a unit, but it is. And our area has a specific unit, and that is whatever the measurement is squared. Wow, this was a lot of fun. I enjoyed this thoroughly. Ladies and gentlemen, I encourage you to please try many of these sums so you get into my way of thinking. If there's a 90 degrees, I use either Pythagoras, SOHCAHTOA, or area being a half base times perpendicular height. If there's no 90 degrees, sine rule, if there's two angles, cosine rule, working with three sides, or the area rule if they're asking me for area. So this is Mr. VG signing out. Have a beautiful, amazing rest of your day. I hope that you are enjoying this time with me as much as I'm enjoying making these videos. So keep well, keep yourself safe, and push, 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 and you will get the marks. Continue pushing yourself. Cheers.